pause now. Okay. Students, now I am defining the new term, that is radius of gyration. This also by definitions will not understand them much. I will read the definition later. Here we know that there is a one square laminar. It's an irregular body or something. This solid body consisting of many a number of particles, m1, m2, m3, so on. And this body is what? Rotating about this axis. About this axis it rotates. This is the x dash is the axis. It is R1, R2 and all that. You know that moment of inertia of x dash equal to m1 r1 square, m2 r2 square, so on. It is mn into what? Rn square. This is the equation. If m1 equal to m2 equal to so on equal to what? Mn, then can I write this equation in this fashion here? I of x dash equal to m into bracket r1 square, r2 square, r3 square, so on of what? Rn square. I am writing. Anything wrong? I am assuming that all masses are what? Centers. This one I will multiply by n and divide by n. I will do it. I x dash m into n. I am multiplying n and also divide by what? N I am doing. R1 square, R2 square, so on. Rn square divided by what? N I am writing. Suppose m into n, nothing but total mass. Suppose this is 1 gram, this is 1 gram, this is 1 gram, like that. There are 10 particles, 10 into 1 equal to what? 10 only. Suppose this is 2 gram, this is 2 gram, and this is what? 2 gram, like this. And then if there are 10 particles, 10 into 2 equal to what? 20. Can I write m into n is nothing but capital M here? What is capital M? Capital M is the entire mass of this object. Okay. Into, what is this? This R1 square plus R2 square plus R3 square, Rn square divided by what? Yeah. This is nothing but m into what? K square. It is what? K square. This K is nothing but the radius of gyration. What is radius of gyration is? It is an irregular body. Here K nothing but where you have to take is, that is a one axis I am taking such that it is passing through its center of gravity. It is passing through its center of gravity. That is, K is nothing but what? Here, whatever the total moment of inertia you are getting now, the same value you are getting if I consider one axis here. At this point, the entire mass of the object is what? Situated, and this distance I will call it as a what? K I will call it as. For example, this is the pen. You see? Here, that is pen will stands on this sharp edge because the entire mass is what? Concentrated at this point. Suppose if I disturb it here or something, I can't hold it. On the edge, I can't hold it. But here I can hold it because the entire mass is what? Concentrated at this point. What is radius of gyration is? It is the distance from the axis of rotation at which the entire mass of the object is what? Concentrated. This is what? K square. K square equal to R1 square, R2 square, R square divided by what? N. Therefore, K equal to square root of what? R1 square, R2 square, so on, Rn square divided by what? N here. Now you can understand the definition of this. What is this? Instead of taking individual objects, I am taking one point where that is what happens is the entire mass of the object is concentrated. This is the point at which entire mass is what? Concentrated. And this point from the axis, it is at a distance of what? K. I think you did simple bar pendulum experiment. Then this knowledge of K is what? Required. Now read the definition. It is defined as the distance from the axis of rotation. It is defined as the distance from the axis of rotation at which the whole mass of the object, whole mass of the body, it is supposed to be concentrated. This is the sentence required. It is the distance from the axis of rotation at which the entire mass of the body is what? Concentrated. You can write this much also, it is good. What is that? It is K nothing but what? It is the distance from the axis of rotation at which the entire mass of the body is what? Concentrated. And students, ನೀವು ಕೆ ವ್ಯಾಲ್ಯೂವನ್ನು ತೆಗೆದುಕೊಂಡಾಗ ಎಷ್ಟು ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಬರ್ತದೋ ಅಷ್ಟೇ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಇಂಥ ಇಂಡಿವಿಜುವಲ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ಗಳನ್ನು ತೆಗೆದುಕೊಂಡಾಗ ಕೂಡ ಅಷ್ಟೇ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಬರ್ತದೆ ಅನ್ನುವಂಥದ್ದು ಹೇಳುವುದನ್ನು ಯಾವುದು? ರೇಡಿಯಸ್ ಆಫ್ ಗೈರೇಷನ್ ಆ್ಯಂಡ್ ಆಲ್ ದಟ್. This distance is also meter only. K unit is also what? Meter only. So that this moment of inertia is kg meter square and all that. Now students, there is two important theorems are there. One is moment of inertia of a perpendicular axis and another one is moment of inertia of a parallel axis. It is very easiest for that. Here normally for the definition and for the explanation you are getting what? 4 marks, and again the 4 marks is there for the parallel axis. This definition at presently don't read it. What this theorem says is, suppose it is a square lamina. Now this lamina is rotating about this axis. It is rotating about this axis. It is rotating like this. It is rotating. This I will call it as a what? X. I will call it as a X about this axis. Next, this object will be rotates about this axis. It will rotates. This is called as in what? Y. Now you see, X and Y, they are mutually perpendicular. This is x-axis and this is what? Y-axis. Now you see, I am considering another axis. I am considering this axis is perpendicular to what? X and Y. Now I am considering one point. I am considering this is the point. This is the point. What are the coordinates of this point P is? Coordinates are X and what? Y. X and Y. Here, moment of inertia of the particle P about this axis. What is this distance is what? It is Y. And this is what? X. Don't get confusion here. Ix equal to m of this into what? Y square. Many of them, why have not written X? No, it is not like that. Because this particle P, it will be rotates about this. This particle rotates about this. What is the distance here? From here to here, the distance is what it is? Y. Next, Iy equal to, you see, this particle rotates about this axis, it rotates. What is this distance here? X. That is what? M into what? X. Y. Here, Iz equal to Ix plus Iy I have written now. This is equivalent to the another axis Z, which is perpendicular to both X and Y. It is like this. Perpendicular to X and Y. Imagine. Now, one axis, it is a whole area. Here, about this it rotates. I think we are able to understand. Or else, here, this is perpendicular, Iz I will call it. This I will call it as a what? Ix. This I will call it as a what? Iy, that is. I think clear now. It is Iy, this is Ix, and this is what? Iz. Iz equal to Ix plus of what? That means what the perpendicular axis theorem says is moment of inertia about an axis perpendicular to its plane lamina is equal to the sum of moment of inertia about the x-axis plus moment of inertia about the what? Y-axis. But here one condition is the students. X, Y and Z should be mutually perpendicular. All are perpendicular, no doubt. Then X and Y should be in the same plane. That I told you that is. This is one X and this is what? Y. This is X, this is what? Y. It is one plane. This is one plane. This board, X and what? Y. What about Z? Z is perpendicular to it. This is another plane. Now, Z should be, where you have to consider Z, the Z should be perpendicular to XY plane and also passing through the, where X and Y are intersect now, ಎಲ್ಲಿ X ಮತ್ತು Y intersect ಆಗ್ತವೋ ಅಲ್ಲಿ Z axis ಬರಬೇಕು. That is what like this. ನೀವು Z ಅನ್ನು ಇಲ್ಲಿ ತಗೊಳ್ಳುವಂಥದ್ದಲ್ಲ, ಇಲ್ಲಿ ತೆಗೆದುಕೊಳ್ಳುವಂಥದ್ದಲ್ಲ. ಇದು X ಇದೆ, ಇದು Y ಇದೆ, ಎರಡು intersect ಆಗುವಂಥದ್ದು ಈ ಪಾಯಿಂಟ್ ಇದೆ. This is what? Z axis. Now you can read it. The moment of inertia of the plane lamina about an axis perpendicular to its plane is equal to the sum of the moment of inertia of the lamina about any two mutually perpendicular axes. Mutually perpendicular means X and Y in its own plane. Important. Intersecting each other. Where they are intersecting? They will intersect. X and Y, they are intersecting at the point. Read carefully. Intersecting each other at the point where the perpendicular axis is passes. This is perpendicular axis. ಈ X ಮತ್ತು Y ಎಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಆಗ್ತವೋ ಅಲ್ಲಿ ಏನಾಗಬೇಕು Z axis ಅನ್ನ ಪಾಸ್ ಆಗಬೇಕು ಅನ್ನುವಂತ ಹೇಳುವಂಥದ್ದನ್ನು ಯಾವುದು? This is what theorem of perpendicular axis. Only the statement is there and also what? This. Don't forget Ix equal to what? M into what? Y square. Iy equal to what? M into what? X square. Because this object rotates about this point. Then what are this is axis. This is your particle. The moment of your definition, mass into distance between the axis and particle. This distance is what? Y. For this axis, mass into what? This distance, because it is rotating about Y axis rotating. This is axis. What is the distance here? X. If want, you can substitute Iz equal to M into what? X square plus Y square. You can write Iz equal to M into what? Y square plus M into what? X square. Then can I write X square plus Y square? This X square plus Y square is nothing but what? R. R square also I can write it. This is about the theorem of what? Perpendicular axis. Students, now let us come to the another theorem. It is the theorem of a parallel axis. Now, what this theorem says is, this is the axis passing through what? X dash. It is passing through center of gravity. I am considering another axis. I am considering this axis. How I am considering is, this is y dash. The y dash is such that it is parallel to this axis x dash. For example, this is center of gravity. It is passing through this, like this. And another one, the axis I am considering here. These two axes, how they are? Mutually what? Perpendicular. This is axis is passing through where? Center of gravity. Or else I will assume like this. This is the one axis passing through its center of gravity. This is x dash. Visualization is required. Imagine yourself. One axis passing through it. And I am considering another axis such that, very difficult to hold, and another axis I am considering like this. This and this, how they are? Parallel. This axis and this axis, how they are? Parallel. What is this axis? It is passing through a center of gravity. And this is the axis passing through its what? One of its end. How these two are mutually parallel things. Okay. What this equation is, movement and this distance I will call it as a what? A D. So that parallel axis theorem, what it says is, I y y dash equal to I of g, it is moment of inertia, it is passing through its center of gravity plus mass of the object, and what is this distance here? Square of the distance. This is what theorem of parallel axis. This theorem is very important while solving the many problems and also deriving the equation for the moment of inertia of the rectangular bar, spherical object, disk, and all that. This is important. Here, still you can understand better way after solving the problems. Read the sentence. The moment of inertia of a body about an axis is equal to its, about an axis means this axis, is equal to its moment of inertia about a parallel through its center of gravity. It is parallel to center of gravity. Plus, that is what I say. Plus the product of the mass of the body and the what? Square of the perpendicular distance. Perpendicular distance is what? D. Of course, there is no proof for you. Even we can prove it also, this equation, how it comes and all that. But normally they will ask what the statement and this diagram they are going to ask that is. In next session, moment of inertia of the rectangular bar is there, the ring is there, disk is there. That I am going to derive it in the what? In the next video and all that. Now, thank you and all. I think you can able to understand by looking into these videos and all that. Okay, I hope that you can understand. If you have any problems and all that, please chat with me, and whatever the queries are there, please put it me. Then I will try to solve your problems and all that. Thank you and all.